It's difficult because a lot of things are very similar, but in case of chikungunya, the arthralgia and arthritis are more common compared to dengue, whereas in case of dengue, the neutropenia, thrombocytopenia are more common. So this is I was always thinking that what is the long-term implication of chikungunya in terms of prognosis, and I found this study which had studied about 180 patients, and overall mortality was not too high, it's almost only about 10%. But there are rare cases of complications, rare cases of encephalitis, means the brain infection, but the persistent severe arthralgia, means the chronic joint pain leading to long-term disability was not uncommon. By definition, WHO definition, a suspected case is fever and multiple joint swelling. Probable case is travel or to the outbreak areas, whereas the disease is confirmed by in cell culture, where we can isolate the virus, or we can detect the viral RNA by RT-PCR, or we can see a significant rise in IgM or IgG. In terms of management, as you know, like many other viruses, there is no specific treatment. It's mainly supportive treatment. And one important thing is to rule out other diseases, such as if it is malaria or other bacterial infection, you really want to treat it. Whereas in case of dengue also, which can be more severe than the chikungunya, so you need more supportive therapy compared to chikungunya. That's why ruling out infection is one of the important things. And other than that, you need to follow the hemodynamic monitoring, do the routine blood test, and you need to keep the patient hydrated. And especially for diabetic patients, it's a little bit concerning because it seems to be that the chikungunya infected diabetic patients have poor glycemic control, so these need to be monitored for the patient safety. And it is basically not recommended to indiscriminately not to use corticosteroid or antiviral agents. The antiviruses that are existing right now would not work at all for this type of viruses. In terms of prevention, the key word is mosquito control. That's the main thing. So other than that, you have to destroy the habitats near your home, and that means you need to separate out the humans from the mosquito breeding site, and this is the most important. And then they normally breed on clear water that are deposited around your home or somewhere. So this is one of the most. Other than that, the travel advisory is another important thing for patients living abroad. I know that, we are all expat Bangladeshis. A lot of us are expat Bangladeshis here, and we frequently travel to home. And we need to take care of that part. And there are community education is another important thing. and then isolating the chikungunya patients, not from humans, but from mosquitoes is a critical important thing because the mosquito is the vector in this case. I don't know a lot about this vaccine, but this is very promising. This is a vaccine coming out, which is now in phase 2 clinical trial. This is actually an interesting vaccine because it looks like a virus without a genome, right? So it's an empty shell of the virus. They call it virus-like particles. So the advantage of these, they are non-infectious, number one, so they are safe. And the second important thing that they retain the natural epitopes, so their immunogenicity is high. So I'm sure this is going to become very soon. So in this opportunity, I want to bring an example of a success story. If you remember how situation was in our country last year, whereas compared to our neighbor in West Bengal, there's not a single case of chikungunya. How did this happen? Think about this. Actually, there are 23 districts in West Bengal. There's not a single case of chikungunya. Actually, the administration over there was really active all year round. And then they make a slogan, right? And the newspaper, they had a wide range of campaign that throw away stagnant water once a week. This has become a slogan. People used to do that. And that's why no outgrowth of the Aedes mosquito, so no transmission, so no chikungunya. For learning points for Dhaka is, we did not pay much attention to this disease. You know the main reason is why? Because people were not dying out of it. We never count the disease a serious problem unless people die out of it very soon. So what happens? So everyone takes it, mildly, but we don't count the loss of productivity, right? We don't count the morbidity. We don't count the long-term disability. So it is really important to do the actual cost-benefit analysis. I mean, even a simpler disease can be, the implication can be devastating, and which is over and over we are experiencing back in our home country. We need to talk about how to do the effective mosquito control. So not only just once a year. It is a persistent thing. You have to control mosquitoes all year round. Otherwise, you would kill mosquito at one place, they'll come from the other places. So you'll never succeed by partially controlling the mosquito. You might have seen this picture in Facebook last year. There are a lot of trolls. This lady, commissioner of Dhaka City, was on a track, and she got two guys around him, and then they were trying to control. So I have seen a lot of criticism as well that the government has spent 34 crore taka to control mosquito, like this is a big deal, right? So, but they don't thinking about the implication of not controlling mosquito could be several thousand koti taka, right? So that's why this lady is my hero actually. She's my hero, she's my champion, because this is what we need. I mean, even if you do it to win election, please kill the mosquitoes first and then win the election. That's what we want to do. So, I am at the end of my presentation, and my conclusion is, it's not possible. This is not a happy story, it's not a happy ending, there's no happy ending. Because a virus would keep killing people, humans would try to destroy the virus, the mosquito would keep biting humans, and humans would keep killing. So the fight would continue. Thank you very much.
Thank you, Dr. Rubasan, for presenting a nice talk. So, Professor of Molecular Biosciences in the University of Texas at Austin, and his area of specialization is plant biology. Here I am inviting Dr. Renal to present his talk.
Hello everybody, I'm from Texas, and I will start with thanking Dr. Arif and the organizing members for attending this reunion. This is an annual event, everybody participates and we come back together as we have done in Carson Hall. We meet new people here. So, Arif asked us to give inspiration. I see not younger people, mostly senior people here. And I guess they do not need any inspiration. But just to add to other colleagues who talked here, if you are hardworking and intelligent, you will be successful in this country. There is no limitation here. So, I think, as Richard shows, that choosing a topic is important. So if you work with big problems in the world, then it's easy to get money and also succeed in scientific research. If you have a smaller problem, it's difficult to get funding. So always try to work on bigger problems of the world. And if you think there are not that many, that's not true. There are lots of big problems, and in fact increasing day by day, instead of solving. So there are lots of big problems you can solve. So, like all of you, I graduated from Biochemistry department. I was inspired by all our teachers. Some of them are here, Kamals are here. When we just started in Biochemistry department. But back then, Biochemistry, as you have seen here, people think, not everybody, that it's more focused on animal science. But I work on plants, and plants do have biochemistry. So I work on light signaling in plants. I'm at the university here. There's a. So when I was choosing where to go for PhD, Anwar sir was at Purdue University working on flood intolerance. And he came back to our department and gave a talk on how to make flood intolerant plants. So that actually attracted me, because I received a fellowship from Rockefeller Foundation to work on plants. So I told Anwar sir that I want to work with his advisor, Dr. Tom Hodges at Purdue University. So that's where I came at Purdue. It was in 93, a long time ago. So after graduating from Purdue, I went to University of California at Berkeley for a postdoc, and that's where I started working on light signaling plants. So I'll give just a brief overview of plant light signaling. So most people think about light effect on plants is photosynthesis. But before photosynthesis happens, plants actually need light as a signal, not as an energy source. And that signal prepares plants for the photosynthesis process. Okay? So plants they can respond to every nanometer of light, direction, duration, intensity of light. So all these parameters they can monitor. And all these, the light signal can control starting from germination to small plant development, seedling development, to flower time, shape control, chloroplast. Many of you are and you might know there's a letter here. It says light, also phototropic growth. So many of these responses are controlled by light. And the way they control is by having a set of receptors, photoreceptors in glands. And these photoreceptors, they can track different nanometers of light. So there are UVR8 or UVB light perception receptor. Phototropics and cryptochromes, they can sense UVA, blue light, phytochromes, the receptor we work with, they perceive red color. So these are about 660, 730 nanometer range. Now we have receptors also. We see light using our eyes, rods and cones for visible light, right? But throughout our body we have other receptors like tryptophan that controls our sleeping cycle or circadian clock. Now these receptors also control many responses as well as circadian clock movements. So we work with phytochromes in a model plant that is related to master. This is called Arabidopsis thaliana. And in these plants there are 5 photoreceptors, phytochromes, 5 phytochromes. And these phytochromes are their dimeric protein and their color protein. Phytochrome, the name came from plant color. And in fact, in 1959, scientists followed this color to purify the protein. And they predicted that now we have purified the protein, so we can figure out what the protein does. And we're still working on it. We don't know exactly what it does. The beauty of this protein is that it has 2 conformations. It's just like a light switch. You can turn it on, turn it off, as long as the protein is stable. So we can turn it on with the red light, 660 nanometer. We can turn it off with 730 nanometer. So this will go sort of convert back and forth. So that's the beauty of this protein. And then these 2 forms of the protein, this is a dark grown plants grown in complete darkness. And this is the PR form of the protein is present in these forms. Okay? So they are not perceiving any light. Now once you shine red light, the protein changes conformation. And then it moves to nucleus and it controls about 30% of the genome. This plant has 27,000 genes. And 1/3 of those are regulated by these receptors. So we were working on how these receptors control the gene expression. So we found proteins, these are transcription factors, these are basic helix nuclease transcription factors that binds to this only PFR form, not the PR form. Now after binding, so these 2 proteins we found that they function antagonistically. So the receptor promotes this development, but this protein promotes this development. So they are sort of antagonistic. So in light, always this protein wins. But in the dark, this protein wins. Okay? So how this protein wins in the light, that's the mechanistic aspect that is important. So what it does is the transcription factor is a substrate for protein degradation. So the receptor binds to the protein and first it adds a phosphorylation using a kinase, and that phosphorylated form is recognized by U3 ligase. That is then ubiquitinated. So this is the target. It puts an ubiquitin chain on it. And this chain is recognized by sort of a shredding machine in our body. So both plants and animals have this. And the shredding machine then shreds only the target protein, not the ubiquitin protein. And this is sort of a continuous process. And so I can show you that the protein will work on each one. You can see 30 seconds or 45, less than 1 minute is the half-life of the protein in response to light. It's very fast degradation. We also showed that these proteins are in the dark, this level, and there is a small shift in the protein after light exposure. So that is due to phosphorylation. Also we can see that in the dark, there is no this higher mobility bands, but these are ubiquitinated forms. So this protein gets rapidly phosphorylated, ubiquitinated, and degraded. So then we work on what are the kinases and E3 ligases that causes this phosphorylation and degradation. So again, like in animal system, plants have different E3 ligases, and these are called kaolin-green ligases, where this is a scaffold protein, has a substrate adapter complex, and it binds to the substrate, and this complex will put into ubiquitination. So just to cut the story short, we figured out there's a CAL4-based E3 ligase that, in response to light, phytochrome causes phosphorylation, and this is then recognized by this complex to cause ubiquitination and degradation. And that's how sort of photoreceptors promote the light mediated program. But in the dark, these proteins are stable and they maintain the dark program. So that's sort of the basic fundamental topics that we work with. But there are many branches of this and many other factors that we work with. So just to show you that finally, and there are several students and postdocs in the lab that are working on these now. Some of these are past students, and we collaborate with many labs throughout the world. And also these are funded mainly by NIH and also by UNICEF, DSF. We also had a human frontier science program grants, and so different funding sources for these programs. That's about it. Thank you very much. I'll be happy to
Thank you, Dr. Anamulha. It was a nice talk. So we move to the final speaker of the session. Our final speaker is Dr. Mohammad Shaukat Anwar, who is a distinguished professor and Associate Dean for Research at Cummings School of Veterinary Medicine in Tufts University. I'd like to invite Shaukat Anwar, sir.
Well, thank you very much for inviting me for this talk. Let me give you a background. I'm probably the oldest biochemist in the group. I'm guessing, maybe not. No, okay, so I am not the oldest person. Yeah?
You're the second.
Second one, okay. So when Arif sent me this direction of what the topic of presentation should be, it was to talk about obviously my research and then my life as a biochemist in terms of what I have learned and not, and then some advice for the new biochemist. And he also told me, okay, you have 12 minutes to do it. So I thought, okay, before coming here, I thought I could be the oldest person. So if I talk longer, nobody will say anything. But then I said, as an older person, I couldn't set a bad example like that. So I should really stay within the limit of the time, okay? So because of that, what I did is, I titled my talk as a Journey of a Dhaka University Biochemist. I'm going to go through this journey, and many of you probably have read this piece from Rabindranath Tagore, who said that life is a journey. You will start someplace. You are going probably a place you don't know where you are going, but the main thing is on the way there, you get to know people who walk with you for a while, and then they get off, go to a different way, and down the road you meet some of them again. So that's life. So I'm going to try with this and tell you
the journey, my journey as a Dhaka University biochemist. So what's the overall journey? So this was 1962, I matriculated. At that time, SSC was called matriculation. We were the last batch. It was in Shorty High School. While I was growing up there, I never thought or dreamed that in 2018, I'll be standing here talking to many, many distinguished biochemists. My point is, sometimes we don't dream enough, and we should really dream about things that goes beyond. First comes the dream, then the reality. If we didn't dream about going to the space, we probably would never have done it. Dream comes first. Well then, as the thing here, you go to college, you get your HSC. So we were the last batch of matriculation and the first batch of HSC. And then, from there, I ended up in Dhaka University and started biochemistry. How did that happen? Did I want to be a biochemist? No. Here's the story. I'm in Shorty Padma. I got my HSC in Rajshahi. My father said, why do you want to go far? There is university in Rajshahi. Go there. It's close. But I wanted to go to Dhaka. So this is what I did. I came up with all this. I said, Dhaka University is the only university who has a biochemistry department. And I love biochemistry and I want to study biochemistry. So that's how I got into biochemistry. And then obviously I fell in love with it. Did my master's. Then I went to Kansas State University in USA for PhD. And I'll tell you why. Then I jumped all the way. I went to Munich University in Germany. And then from there, I went to University of California in San Diego. And from there, I went to Tufts University in the School of Veterinary Medicine. And this is my current position. So what I do is, let's take the journey with me. Since I'm getting in a position, at an age where I remember old things more than the newer things. So what I will do is I try to reminisce with you some of my time at Dhaka University, and then I'll give you a brief things that I have done since then. So let's just start with Dhaka University. By the way, when I was leaving from Dhaka University for my PhD, Professor Kamaluddin Ahmed told me that, remember, these 4 years that you have been at the university will be the best time you ever had. I didn't believe it at that time, but it is true. That's the most carefree time you have when you are learning. Basically no obligation, you know, that's the best time. So here is the class of 67, biochemistry honors class. Not everybody is here, but see, this is Kamaluddin Ahmed, this is Dr. Mutir Rahman. I'm sorry, even my old age, I can't remember their name. He used to teach physiology. Remember, in the beginning, when the department was created, it was biochemistry and pharmacy. Those were together. Biochemistry, pharmacy department were together. Okay. You probably know this. This is Ahmed Abdullah Jad, who sends you a lot of email and through the business. This is the other Chaudhary, who was the chairman of the University Grants Commission. right here. And these are some of our classmates. Those who are there. So very good, quickly. Remember those were the days when gas liquid chromatography was just coming. And one of our projects was to make one. And as a part of a science fair, we made one in GLC. It was functional GLC. You know, we got the copper pipe, filled it up first with the diatomaceous earth, and then put them around to make the column and make all the connection. And that won the first prize in the science fair we had in '67. We used to play. You can see the sign here. That's me. He says Biochem Farm. That's the Department of Biochemistry and Pharmacy. On our logo, we were there. Play soccer. We were in that year interdepartmental championship. We were playing against departments from arts and sciences, you know, and all of them. And that department we won. This is, I was selected as one of the 80 students. We were selected for cultural exchange, representing Dhaka University. So I was one of them. In the middle sitting is my chancellor at that time. Yeah. And on his right was the student representative from Rokia Hall, the female student. On the left was what do you call that? Not the provost. Who is in charge of the residential hall? Yeah. Was for the Rokia Hall at that time, Rokia Hall provost. Okay. This is one picture. I got to give you an introduction. The science faculty was always a very conservative faculty, in the sense that they wouldn't make any political statement. It was the student who did the politics, but the teachers were in the back. Not now, I know, but this was the first time that the science faculty went on a protest march. You know, and this is obviously just before the independence war because of the thing. And if you look carefully, that is Kamaluddin Ahmed, the chairman of the Biochemistry department at that time. Okay? And this is the chemistry building. In front of the chemistry building we had a cover, and that's where So what did I do in Dhaka University this time? Very simple. I got my Bachelor of Science or the honors, which to call them at that time, 1967, 1968. I got the Master of Science degree. I was working under Professor Kamaluddin Ahmed, and I said it jokingly, chasing Vibrio cholera toxin. My job was to isolate the toxin. We got picked by people somewhere else. But anyway, the main thing was, that's the time when Mustafizur Rahman, Mustafiz Bhai was 1 year senior to me, helped me a lot in many of the techniques. And here is a picture of him with me in 2005. I told Arif, as you know, he passed away recently, and I'd like to set up, with your help if possible, some kind of a memorial lecture in honor of Dr. Mustafiz Rahman. He was probably teachers of many of you when you were there. So we'll talk about it and think about it. In 1969, after a master's degree, I was appointed as a lecturer in the department. And then I got the Fulbright scholarship to go to USA in 1969. Kansas State University is where I was. So you do the usual coursework. For my PhD, there was one thing that program had, that you had to have a rotation in 2 different labs, unrelated to your PhD work. And that I found was very helpful for me in expanding my knowledge in other areas, learning other techniques. So if you have that opportunity, do take that opportunity to learn something beyond your field. Because very often once you are working in your field, you have a tunnel vision of the field. And then you go to a seminar, go to someone else, and they talk about something else. Like we did today. Look at all the speakers, all the different topics they have covered. And that really enriches, and then you can go back and say, oh, maybe I can try that. You know, maybe that technique will be good to solve some of my questions that I'm trying to answer. That's very important, rotations. Then PhD, my PhD was built in pharmacokinetics. My lab rotation was enzyme kinetics and glucose metabolism. Not a problem. And with each one of those, I have publications from it. So. And then I did 1 year postdoctoral fellow. Folks, this is the time to publish. You did the work, and make sure during your postdoctoral phase, you have published all of your graduate work, if possible. If you didn't do that, you are not going to have time to do it, and the data in your drawer is not going to get better. Okay? You need to publish that. It's very important. These days, if you want to survive and continue to get grants, publication is very important. Pay attention to that. And I said also, teach. Think about getting some teaching experience. Giving a lecture to a group like that and teaching a concept to a class full of undergraduates or new graduates, it are different things. Learn how to teach. Why I'm emphasizing that? I served as a chair and I also served as a dean, associate dean for research. When we are hiring people, very often we are hiring people for the research work. But in the back of our mind, we're thinking, what happens if the research funding doesn't come through for this person? How can we use the person in our system? And the hard money position is in teaching. That's where university has the money. So if there's a quick way to convert somebody from a research to teaching, that's what we want. Because we don't want to waste the time of go and find another person. If we have a person doing research and also teach, it makes it a lot easier to move them there and justify the funding situation. So keep that in mind. Take every opportunity to do some teaching. It's very important for you. And then I went to Germany. By the way, when I was a postdoctoral fellow, I had the opportunity to teach a regular course, a section of regular course in veterinary medicine. That was very helpful for me to organize, a section which was neurophysiology to veterinary students. So here we are in Germany. This is called the Fakultät der Tiermedizin, Maximilian-Universität München. By the way, why did I go to Munich? I was on a Fulbright scholarship. If you come on a Fulbright scholarship, you are on J visa. If you're on a J visa, after you have completed the study, you have to go back to your home country. You have to leave the United States for 2 years. Look at the time, 1974. I went to Bangladesh. I talked to Kamaluddin Ahmed and said, can I come back? So Dr. Kamaluddin Ahmed said, sure, come back, we'll find something for you. He didn't tell me you will have a position here. I knew I could find it, but then we had a lot of loss during the war. The whole country, all our property devastated. 3 of my brothers died. So, it was difficult. So I said, okay, I'm not going to go to Bangladesh, but I have to leave the United States. I ended up in Germany. What did I do there? I had research grant from the Deutsche Forschungsgemeinschaft, which is equivalent to German NIH. And I was working on characterization of sodium chlorofolate co-transport system, bile formation. Basically, my studies were mechanism of bile formation. And the reason we need to know this simplest example is jaundice is a problem of bile formation when you get jaundice. So at that time, I also taught to the first year students there. My degree was Dr. Batman Habil. I abbreviated DMBH. So this is the time I got married, and my first child was born there. So glad my wife is here. Okay. So if you ever want to talk to her, in 1980, then I moved back to the United States as a permanent resident. Okay? So this is a research assistant professor at UCSD. So this is where my research started, mechanism of bile formation over spaces. I taught in physiology lab to undergraduate. Remember, I'm emphasizing this, that every time I research also had teaching component to it, which in my mind was helpful. I got my first NIH R01 in 1982. I like with mental support for safety. My second child was born. We have two children, a son and a daughter. My daughter was born here in San Diego. Mentor support. Somebody mentioned about choosing mentor for postdoctoral fellowship. Mentor support is very important. If your mentor is not supporting you, you will have difficult time moving forward. So it's very important to choose the right mentor. Recently, I think NIH has pushed it because I was involved in some of those committees, is that for the training, every graduate student and postdoctoral fellow should have what they call it, individual development plan. IDP is the name. If you haven't heard about it, don't know about it, look for this. This is a requirement now that any institution who is providing training, they should have an individual development plan for the student. And basically what this is a postdoc or a graduate student. Requirements are a little bit different for graduate student versus postdoctoral fellow. But it's important for postdoctoral fellow to have a development plan. And your mentor should be helping you to reach each one of those milestones. So as an individual postdoc, you should create those milestones. At Tufts University, we have a guideline. We provide the IDP. Okay, what do you want to do? What have you done? What are the new things you want to know? Things like, I'm doing very good in research, but I need to get some teaching experience. Can you manage it for me so that I can put it in my CV, and next time I'm applying for assistant professorship, people will see, yes, I have teaching experience. That is important, okay? So think about IDP. And my mentor was very helpful. At that time, we didn't have IDP. He told me, you should be a member of this association because that is what is going to help you down the road. He wrote for me, make me a member of an association, okay, that he thought is going to be important for my career, okay? When I had the opportunity to teach, he said, definitely go teach, okay? You need to do that. So support the mentor is very important, and, you know, keep that in mind. 1983, that's when I moved to Tufts University. Here is the Cummings School of Veterinary Medicine. That's the library building. This is where I established my own lab the first time, and to study the mechanism of bile formation cholestasis. I was hired to teach veterinary pharmacology, so that I did that. And then I was lucky to have NIH grants from 1983 to 2016 when I gave up my lab, and I still have a NIH T35 training grant for training people. I have a few awards I get praised, so I just put it in a German word in there. I received few awards during the process while I was at veterinary school. So what is my scientific contribution? I show you one slide with my scientific contribution to the field. Okay? So what I was looking at is regulation of hepatobiliary transporters that are involved in the formation of bile. Since regulation is the key, I was looking at regulation by Rab proteins, protein kinase Cs, and P38 MAP kinase. So, close to 35 years of work, I put it in one slide. And this is what I found. Not going to go through there, but what it does, it shows you the role of each one of the signaling molecules in the process of a transporter moving into the membrane and the transporter moving out of the membrane. Okay? So when I was studying this, this transporter, NTCP, okay, transport bile acid from blood into the liver, big deal. Okay, good. If you didn't do it, you'll get a high level of bile acid and cause itching and things like that. But what happened is the recent studies, not my study, other people, what they found is that the viruses, hepatitis B virus and hepatitis D virus, they need this transporter to get into the cell. And now the transporter gets a lot of mileage in terms of understanding, so how can we manipulate this transporter so that the virus cannot get into the cell? It's not my work, somebody will do it, and hopefully it will lead to something in the future. So what am I doing now? I have two projects. I've been trying to spend a lot of my time as much as I can to do something for the country I came from. So I have some Bangladesh projects going on. We have one project, it's called OIE, which is actually World Organization for Animal Health. And they have given us a grant to help improve Bangladesh veterinary education. And we are doing this in collaboration with Chittagong Veterinary and Animal Sciences University. So this is like, we are having a session of problem-based learning, and our professor, I forgot his name, who talked about the disease movement from virus to mosquito. This here? What's the name? Dubai, huh? Here. And this is what you do, in problem-based learning. You take the problem and then try to solve it. It starts with the various things, like you were saying, a patient came in with a high fever, these, and these, and you work it through. And in the process, you learn everything about that disease. And then through this program, we have also a exchange program. Every year, 40 students from this university will come and visit Comics School and know the clinical facilities we use. Mostly these are the final year students from there, and they'll come, and this is when they make a presentation. The other project we're working on is FAO, Food and Agriculture University Bangladesh, which is disease control and prevention training. That means, again, they train the veterinarians so that they are better able to help with the control and prevention of diseases, especially zoonotic diseases that go from animal to human. And this is the graduation. We were training some faculty. That was the last session. They're showing their certificate that they graduated from the course. So I have been doing research from 1969 when I started my master thesis and until now. So that's close to 50 years. What did I learn? So I'm going to share with my overall what I learned with you. So that's why the title, Lessons Learned. So let's see what I learned. So this is what I say. To have a successful scientific career, one needs support. Whose support? Support from your family, need support from your mentor, you need support from your peers because they are the competitor. So when there is a healthy competition, you win. Okay? So you need that peer competition and you learn from your students. Like, how am I doing with time? The reason I say the student is I learned it firsthand. because the students are most naive and they will ask you the most naive questions. And when they ask the question, that's when you realize you never thought that and you really don't have an answer. Never give them the wrong answer. Tell them, okay, I don't know the answer, I'll find it. I'll give you an example. I was teaching in Germany, and the German veterinary school, the students come based on their grade level, whether they have science background or not. So in a class, you will see students who are very good in arts and science, arts, but do not know the symbol for hydrochloric acid, for example. And you have other, they have organic chemistry already. So that's anyway. So I was teaching sodium potassium ATPase. What it does. I thought it's simple. I'll tell them, you pump sodium out, potassium in, and you're good to go. That's why you maintain your potassium gradient, electric activity, so on and so forth. That wasn't enough for this student from arts and sciences. See, the arts people, they think differently, which is good. You need to get contact with them. They think differently. So the question is, why do we have it this way? Why is not the other way around? Very valid question. Yeah. Why are we pumping sodium out and potassium in? Why not do the other way around? Okay, luckily I was good. I knew that answer. Because all life started in the ocean. Ocean had high sodium concentration in the water, so the cells were getting bombarded with sodium coming into the cell. They need to find a way to get the sodium out. You cannot take one cation out because it's going to mess up the electroneutrality, so you got to put another cation in. So she kind of bought that. Then she said, why do we have high sodium in the ocean? I tried to explain, all right, all this water coming in, evaporation, sodium came in, but she wouldn't give it up. It was a she. Why there's more sodium in the ocean water than potassium? I was stumped. I couldn't do anything. I said, okay, I don't know the answer. I'll try to find it. So I went back. Now you guys remember your chemistry? From way back, remember we learned all alkali metals are soluble in water? Remember that? In the, the HSC in chemistry, those rules. We looked at the periodic table. I said, okay, this is the alkali metals, they're all soluble in water. Guess what? Sodium and potassium belong to the alkali metal series there. Okay? And not only that, it turns out, and I found the information in an old inorganic chemistry book written by a German. I was in Germany, I happened to have that book handy, and I found the answer. Now, we also learned that there are 2 or 3 potassium salts that are not soluble in water in that series. So this is what happened. When the ice was melting, and it was bringing the topsoil, dissolving the chemicals in the topsoil, and then moving it down to the ocean. First of all, it couldn't bring all the potassium salt with it because some of the salts were not soluble. Then when you got to ocean, whatever potassium salt came, starts settling down the precipitating. Then over the millions of years, we have an ocean with high sodium, low potassium. And the life has to start with that environment, have to come up with a way to get rid of sodium, and in exchange they ended up having potassium. If you go at the bottom of the ocean, it's around the other way around. There are more potassium. My point, if the student never asked me that question, I would never have gone back to the book and tried to find out this answer. So that's what I'm saying. It's a long way of saying how we learn from the students, but please, let them ask questions. That's when you start learning, in my mind. So family is important, and I have a picture of my family here, just to show you. My wife and 2 children. This is a little older picture. we look a little younger, and I wanted to make sure my wife was okay showing this picture, although I didn't tell her ahead of time, so okay. Support of the family is very important. You don't really recognize that. It's very important. You bring your family as much as possible, the daily challenges you face. I'm not very good at that, and I'm just realizing after 50 years of doing this. So, okay, if you can do it early, do it. It's very important. The other thing I said about your students, make sure you spend the time talking to them in the lab, learn from them what the problems they are having and things like that. Now I'm going to give you some very general advice that I think are important. Lessons learned. It is not who you are, it is who you know. Very important. Think about it. Message, get to know people. When you go to meetings, get to know your competitor or peers or other people. If they know what you are doing, at the right moment they'll be able to say, yeah, I know that person is working on that and this is good, okay? Very important. Things happen when least expected. It could be good, it could be bad. I was lucky for this, very often it was good. But this is what I was saying, you know. Expect things. Don't leave it up to chances. Okay, as much as possible. Even then you're going to have a lot of unexpected things there. That is, anticipate things. And that is what you do when you are doing research. Not only that you have a hypothesis, you also think about, just in case, if this is not the way it's going to happen, what could be an alternate explanation? Expect things. Just don't go there. It didn't happen, now what? Be prepared for things. In most cases, this hypothesis is not going to work out. So always think about it. And the last thing I want to say, this is my personal thing, try to help others without expecting anything in return. Try it, you may like it. With that, I thank you very much with the picture of my hall. We used to call it Dhaka Hall. Now I think they have changed the name. And I thank you very much for your attention. Much appreciated. Thank you.
Thank you, Dr. Shokatanon, sir. And we enjoyed a great scientific session here. And attention, please. We are now moving to DUBANA award session. So I would like to invite Dr. Shokatanon, sir, to the stage to present the first award. Dr. Shokatanon, sir. So, our first awardee is Shahabuddin Memorial Award, which is given to Mr. Mamunur Rashid. Please, Mr. Mamun, come to the stage. Shahabuddin Memorial Award is given to Mr. Mamunur Rashid by Dr. Shokatanon, sir. Give a big hand for Mamun. Gift card given to Mr. Mamun. It's a $100 Amazon gift card. Give a big hand for Mamun again. Our next award we will give for the abstract submitted awardees, and I would like to invite Dr. Nouri Kamal sir to come into the stage to present the award. Okay, I will call the name sequentially. Our first awardee is Mr. M.A.G. Rabbani. Mr. M.A.G. Rabbani, please come to the stage to collect the award. The award is a $50 Amazon gift card given to Mr. M.A.G. Rabbani. Give a big hand for Mr. M.A.G. Rabbani. Okay. Our next awardee is Miss Fahmina Ahmed. Miss Fahmina Ahmed, I'd like to invite you into the stage and collect the award. It's a $50 Amazon gift card. Here is Miss Fahmina Ahmed. Give a big hand for Miss Fahmina Ahmed. Okay, our next awardee is Miss Tanjina Akhtar. Miss Tanjina Akhtar, please come up to the stage and collect your award. Miss Tanjina Akhtar. Yeah, here is Miss Tanjina Akhtar. Give a big hand for her. Okay, I'd like to invite Dr. Faisal Khan, Faisal Bhai, to come into the stage to give the remaining awards. Big hand for Faisal Bhai. Our next awardee is Mr. Mohammad Farooq Hussain. Mr. Mohammad Farooq Hussain, I invite you to come into the stage and collect the award. Faisal Bhai is giving the award to Farooq. Give a big hand for Farooq. Okay, our next awardee is Mr. Muhammad Mahbubur Rahman. Mr. Muhammad Mahbubur Rahman, please come to the stage and collect the award. Big hand for Mahbubur Rahman. Yeah, thank you very much. Our next awardee is Miss Marjia Afrin. Miss Marjia Afrin, please come into the stage and collect your award. Faisal Bhai is giving the award to Miss Marjia Afrin. Give a big hand for Marjia. And our final awardee of this session is Mr. Shohid. Mr. Shohid, I'm inviting you to come into the stage and collect your award. Give a big hand for Mr. Shohid. $50 Amazon gift card. Yeah, thank you for presenting.
There is a small story behind this award. I remember when we decided about this Dr. Shahabuddin Award, and that was from our the batch 88 batch. They sponsored that one. Then I thought that we have remaining 8 abstract submitters. They submitted abstracts, but like there was nothing we can provide, offer them. So I sent an email to Shaukat sir, and I told him that probably we can give something to that, like $50 and other gift cards. And the next morning, what I saw in my PayPal account, that is $350 in my account. The DUBANA PayPal account, Shaukat sir immediately transferred $350, and that's what we distribute right now. And if you see the Amazon gift card, there is a small sticker and it's written that is sponsored and supported by our Shaukat sir. Thank you, sir.
Class of
68, not me.
Okay, we are moving to our next award. Our next award is DUBANA Appreciation Award. And to give this award, I would like to invite Dr. Islam to the stage, please. Yes. Yes, sir. It's our honor to have you in the stage. And DUBANA Appreciation Award goes to Dr. Ejharul Haq Chaudhary. Please come into the stage and collect the award. Give a big hand for Dr. Ejharul Haq Chaudhary. I would like to mention that Dr. Ejharul Haq Chaudhary came from Malaysia to join this meeting, and we are really honored to have you in this meeting. Give a big hand. Give a big hand. Thank you, sir. With that note, we are closing our ceremony here.